Hello everyone, this is Dr. Vinay Kumar, Associate Professor, Mechanical Engineering Department. Today I'm going to explain you stress strain diagram of mild stress. So this is the diagram. Here y-axis indicates the stress, x-axis indicates strain, and O point is the origin. If you see that the O to A, that is the limit of proportionality, it means there is a straight line. A to B, there is a slight change on that. Some curvature will be there, and B to C is straight line. And the C to D, you will see the curvature will increase. C to D is strain hardening, and D to E is fracture. That is called necking. So we will discuss one by one. That is elastic behavior. The curve is straight line through move out most of the region. Stress is proportional with strain. Material to be linearly elastic. Proportional limit, the upper limit to be linear line. The material will still respond elastically. Elasticity means what? When you apply a force on it, for example, we will take up an example of elastic rubber. If we stretch on it and release it, it will come to the original force. That is the elastic. The curve tends to bend and fallen out. Elastic limit upon reaching this point is the load is removed. The specimen will return to the original position. So here we will see that O2 is a straight line that is called limit of proportionality. It means stress is directly proportional to strain. And if you see that A to B, that is a elastic limit. That is elastic limit. Elastic, up to elastic, A to B. But after that elastic behavior, yielding will be start. Yielding means deformation will be takes place. A slight increase in the stress above the elastic limit will result in breakdown of the material and causes it to deform permanently. This behavior is called yielding. It means yielding is what somewhat is it the shape and size of the object will be changed. It means what? When we consider a one rod over there, apply a force on it, it stretch something. When we release the force, the stretch part will be as it is after removing the force. It means it is what? It is stretched or deformable body. The behavior is called yielding. The point that cause yielding stress or it means when the object release, when we apply a force on the object, release the force, it cannot come to the original position. That is plastic deformation. Once yielding point is reached, the specimen will elongate strain without any increase in load. Material in the state that is called perfectly elastic, not elastic. That is a plastic. It means the shape and size will change. Plastic. Strain hardening. When strain hardening is ended, further load must be applied on it, result in a curve that rise continuously, becomes flat when reach ultimate stress. It means when we apply a force on it, we will, for example, we will take up an example of plastic bags. Apply a force, and certain time you will see that you are applying a force, but it is not elongate. That is called strain hardening on it. So for that, we required much amount of force on it so that it will comes to the ultimate or maybe it will be necking and then it will fracture. While specimen is elongate, so again specimen is elongating, its cross sectional area will be definitely because we are applying a tensile forces. The cross sectional area of the object will be definitely decreases. These decreases is fairly uniform. And then when we will see that if I'll take a one rod and apply a force, tensile force on both of the sides, the diameter will be definitely decreases. At certain time, it becomes strain hardening. So that at that time, I have to be increase that is the load so that it will elongate more. When the diameter, for example, the diameter of the rod will be 20, apply force, it will become maybe 18. So slowly apply, increases the load on it. So the low diameter will be decreases by maybe 15, 10, just like that. So it is called necking. So at the ultimate stress, the cross-sectional area begins its localized regions of a specimen. It is caused by slip planes formed within material. Actual strain produced by shear strain as a result neck to form. A smaller area can also carry lesser load, hence curve downward. since break at fracture stresses. So again, we can come to the this reason. Okay. So again, we will study this. So O to A is the limit of proportionality. A to B is elastic limit. It means if it is still apply a force, it will come back. But after B, it becomes yielding stress. Yield means the shape and size will be definitely change. So B to C is a constant line, yeah, yielding point, and then after C to D is strain hardening. Strain means applying a force on it, the strain will be increases continuously. But after D, at D is a ultimate stress. At that time, we have to increase much load on it so that after D to E, E point is a fracture point, or D to E is a necking. Necking means you will see that the neck, so you will see that the diameter of the rod will be decrease, and then after it will fracture. Now, next topic is shear stress. Shear stress is small means what? Is a force applied sideways of the material. For example, if I am consider this mobile, you can apply one force from here and here. So that two equal opposite forces having some distance on it, tangential force, you can say that, apply on it. So when a pair of shear cut a material, when a material is punched, that is also shear. Something you are going to cut, that is what? Shear. When you apply a punching on it, that is also shear stresses. On the beam, when you transverse load applied, that is also an example of shear stress. Shear stress is force per unit area carrying the load. This means the cross sectional area of the material being cut. The beam. Shear stress is also, you will see that force upon area, and symbol is called tau. The sign convention of the shear stress, shear forces is based on how it shears material. Positive shear force, upward direction and downward direction. This is the positive shear stress. If this is up and down, the negative shear stress is just reverse of it. Shear stress. Because of shear stress, the shear strain will be occur. The force causes the material up to deformation. The shear strain is defined as the ratio of the distance deformation to the height. X this. Since it is very small, that is known as gamma. We can say that gamma is x upon L. The modulus of rigidity we can find out with the experiment measuring the x for various values of force. We would find that if material is elastic, it behaves like a spring. So long as we do not damage the material by using two big forces, the graph F and X is a straight line as shown in the figure. The gradient of the graph is constant, F by X is a constant. This is a spring stiffness of the block in Newton per meter. If we divide F by area A and X by height and L, the relationship is still constant and we get. These are the formulas. So F stress, strain, and then we will get that G. G's indicate for modulus of rigidity. Sometimes in some books it is also write down with the capital C. Tau is what? Shear stress. Gamma is shear strength. So it is the ratio of shear stress to shear strength. Ultimate shear stress. If a material is stressed beyond a certain limit, it becomes permanently restored and does not spring all the way back to its original shape. The elastic limit exit. If the material is stretched to the limit, so it parts into two, the ultimate limit has been reached. The ultimate shear stress has tau, and this value is used to calculate the force needed by the shear approaches. These are the some examples. I'm going to consider X one a small wire 2.5 diameter, 2 meter long. Force on 12 Newton is applied on it and its stress zero point 0.3. Assume the material is elastic, determine the following stress. So we will know that stress is equal to force upon area. So we can have a value of 12 newtons. Area we can get because it is a steel wire, so diameter, so pi by 4, pi by d square by 4, that is area. So the value of 2.44 Newton per mm square. And the strain is x upon L, that is changing length upon original length. So it is stress zero point 0.3, so we will put zero point 0.3. And the 2 meter long, so we will convert that 2 meter into mm, and then we will get the value of 0.00015, that is the strain. Similarly, there is an assessment if you want to solve that. So you can solve this. Example 2, have we just have a look of it. Example 3. So this is some kind of different questions. But in this, you will see the modulus of elasticity is different only. This is another cell person. Work number 4, you will find the shear stress on it. Thank you very much for giving your valuable time. Thank you.